So differentiation exercise 1.5. We will continue the same. This is our last lecture on this exercise 1.5. Find the nth order derivative of the following: cos of 3 minus 2x. So let y is equal to cos 3 minus 2x. Differentiating with respect to x, we get the derivative is d by dx of cos of 3 minus 2x is cos f of x. Its derivative is minus sin f of x into f dash of x. Now here derivative of 3 is 0 and derivative of minus 2x is minus 2. Now again, as I told you that whenever the function is cos, sine is there and we want to find the nth order derivative, the derivatives will be alternately cos x, sin x, cos x, sin x. So we have to keep in your mind that we have to continue with only one function every time. So I will have converted this minus sine theta into cos 90 plus theta. So this cos 90 plus theta into minus 2. So kept this minus 2 in front. So dy by dx is equal to minus 2 into cos of pi by 2 plus 3 minus 2x. Now again differentiate this equation with respect to x. So minus 2 into d by dx of cos pi by 2 plus 3 minus 2x. Now minus 2 is a constant. We can keep it as it is. Now derivative of cos theta is minus sin theta into d by dx of that theta is pi by 2 plus 3 minus 2h its derivative. Now pi by 2 is a constant, 3 is also constant, both will have the derivative 0. So the derivative of minus 2 into x, again minus 2 is a constant and derivative of x is 1. So here the derivative is minus 2. So minus 2 into the previous minus 2, that combined together we get minus 2 its square. Then this minus sin theta, I can write it as cos 90 plus theta. Then pi by 2 and this pi by 2, I will write 2 times pi by 2. So minus 2 square into cos of 2 times pi by 2 plus 3 minus 2x is the second order derivative. Now we will go for the third order derivative. So differentiating with respect to x, minus 2 square constant cos of f of x is minus sin f of x into f dash of x. So minus f dash of x means this derivative of this. So again after taking the derivative from this factor, I will get only minus 2. That minus 2 and this minus 2 square, you get minus 2 and this minus 2 square, we get minus 2 cube. Then minus sin theta can be written as cos 90 plus theta. So cos 90 plus theta and this 90 plus 290 is 390 and we get minus 2 cube into cos of 3 pi by 2 plus 3 minus 2x. So if we look at this third order derivative, we can generalize this concept to find nth order derivative. So dny by dx raised to n is minus 2 raised to n into cos of n times pi by 2 plus 3 minus 2x. This is the nth order derivative of the given function. Now the second example is log of 2x plus 3. So y is equal to log of 2x plus 3. Differentiate with respect to x, dy by dx is equal to d by dx of log 2x plus 3. So log of f of x, its derivative is 1 upon f of x into f dash of x. So derivative of this f dash of x is only 2. So 2 upon 2x plus 3 is the derivative. Again differentiating the same function. So we get 2 is a constant, d by dx of 1 upon 2x plus 3. So here I will use 1 upon f of x. Derivative of 1 upon f of x is minus 1 upon f of x square into f dash of x. Again d by dx of 2x plus 3. 3 is a constant, derivative is 0. And derivative of 2x is only 2. So again I will get 2. This 2 and the previous we got 1 2. So 2 into 2 is 2 square. So minus this minus sign, minus 2 square 1 upon 2x plus 3 bracket square. So if I write this minus 1 into 2 square into 2x plus 3 bracket raised to minus 2 using laws of indices only. Again differentiate with respect to x, so minus 1, 2 square constant. So we have to find the derivative of only this 2x plus 3 raised to minus 2. Its derivative is minus 2 into 2x plus 3 raised to minus 2 minus 1 minus 3. And derivative of this 2x plus 3 is 2. Now minus 1 and this minus becomes minus 1 square. Then this 2 and this 2, we get 2 cube, and this 2 into 1, I can write this 2 as 1 into 2. Then this is d cube y by dx cube, so third order derivative. So by generalize we can find the nth order derivative as dny by dx raised to n is minus 1 raised to n minus 1, because whenever there is 3 it is minus 1 square, so 1 less than that order, so n minus 1. Now 2 raised to 3, so here 2 raised to n. So 1 into 2, so 1 into 2 into 3 into n minus 1, and 2x plus 3 raised to minus 3, so 2x plus 3 raised to minus n. So but here this is the product of first the n minus 1 natural numbers, so it's it is n minus 1 factorial, and using laws of indices we can take this term to the denominator. So dny by dx raised to n is minus 1 raised to n minus 1 into n minus 1 factorial into 2 raised to n upon 2x plus 3 bracket raised to n. This is the derivative of the given function. The next example is the nth order derivative of 1 upon 3x minus 5. It is simple. Dy by dx is minus 1 upon 3x minus 5 into derivative of 3x minus 5. 1 upon f of x minus 1 up, its derivative is minus 1 upon 3x minus 5 bracket square into dy by dx of 3x minus 5. So dy by dx is minus 3 upon 3x minus 5 bracket square in is equal to 3 is as it is, then minus 1 and 3x minus 5 raised to minus 2 using laws of indices. So we will differentiate this with respect to x again. So 3 is constant, minus 1 is constant, we can take outside, and d by dx of 3x minus 5 raised to minus 2. Now its derivative is minus 2 into 3x minus 5 raised to minus 3 minus 1 minus 3 into derivative of this 3x minus 5. Again the derivative of 3x minus 5 is only 3. So the first 3 and this again we are getting 3. So 3 into 3 is 3 square into minus 1 square into 1 into 2 into 3x minus 5 raised to minus 3. This is second order derivative. Again we will differentiate the same function with respect to x and simplify. So we get 3 this 3 square into this minus 3. So I will take only 3, so 3 cube, and this minus 1 I combine with to this minus 1 square. So minus 1 square into minus 1 cube, then 1 into 2 into 3, then 3x minus 5 raised to minus 4. Okay, so this d cube y by dx cube is 3 root, we get 3 cube minus 1 cube, 1 into 2 into 3 into 3x minus 5 bracket raised to minus 4. So from this third order derivative we can generalize, or we can find the nth order derivative by dny by dx raised to n is 3 raised to n minus 1 raised to n, 1 into 2 into 3 into up to n, again 3x minus 5 raised to minus n plus 1. Now here it is a product of first n natural numbers, so it is n factorial. So 3 raised to n minus 1 raised to n factorial, 3x minus 5 raised to minus n plus 1 is the derivative of the given function. The next example is find the nth order derivative of y is equal to e raised to ax cos of bx plus c. Now y is equal to e raised to ax cos of bx plus c. Differentiating with respect to x, dy by dx is dy by dx of the given function. Now here you have to use the product rule. First function as it is, derivative of the second function, plus second function as it is, derivative of the first function. Now derivative of cos of f of x is minus sin f of x into f dash of x, and derivative of e raised to f of x is e raised to f of x into f dash of x. Now here derivative of bx plus c is only b, and here derivative is a. So now we can take their e raised to ax common from both these terms, and this is the positive term, so I will write it initially, and the negative term I will write afterwards. So e raised to ax into a cos bx plus c minus b sin bx plus c. Now I will convert this bracketed term into sin a plus b or cos a plus b, whatever the formula I will get. But this initially we are given the y in terms of cos, so I go for cos. I will convert this into cos of a plus b or cos a minus b. Now here it is minus, so I must get the cos a plus b only. For that, as the coefficient of this is a and the coefficient of this term is b, so I will multiply divide, is the adjustment, multiply divide by root a square plus b square. Okay, and then this a upon s root a square plus b square I will call it as cos alpha, and this b upon root a square plus b square I will call it as cos sin alpha. So if I take the ratio of this sin alpha upon cos alpha, I will get tan alpha as b by a. Call this as equation number 1. From this I will write alpha as tan inverse of b by a. Now the equation becomes cos alpha cos bx plus c minus sin alpha sin bx plus c. So it is nothing but cos a cos b minus sin a sin b. Okay, so cos of bx plus c plus alpha cos a plus b. Now this is the only first derivative we have obtained. Now again we will differentiate it with respect to x. So d2y by dx square is equal to root, now this is constant, so we can keep outside. Then derivative of e raised to x cos bx plus c plus alpha. So again here there is a product of functions, so we have to use the product rule, curly bracket, first function as it is, derivative of the second plus second function as it is, derivative of the first function. So the derivative of the first function is second function is minus sin bx plus c plus alpha into d by dx of bx plus c plus alpha. Now its derivative is only b because c is constant and alpha is also constant, both are having derivative 0. And so we get root a square plus b square in curly bracket e raised to ax minus sin bx plus c plus alpha into b, and plus a e raised to ax cos bx plus c plus a. Now again I will take the common for e raised to x from both these terms, and what I will do, this positive term I will write first one, and this negative term I will write in the next part. So here again I am getting a cos minus b sin. So again I will multiply divide by root a square plus b square, and this a upon root a square plus b square is cos alpha as usual, and b upon root a square plus b square is sin alpha, that I have we have put it in the previous step. So what we get, e raised to ax a square plus b square is to half into root a square plus b square cos a cos b minus sin a sin b. It is nothing but cos of a plus b, and this root raised to half I can write it as a square plus b square bracket raised to 2 upon 2. So this is the second order derivative. On the same line we can obtain the third order derivative as d cube y by dx cube is equal to e raised to ax into a square plus b square bracket raised to 3 by 2 cos of bx plus c plus 3 alpha. So from this I can generalize. From this I can generalize, and I will write the nth derivative as dny by dx raised to n is equal to e raised to ax a square plus b square raised to n by 2 cos of bx plus c plus n alpha, where alpha is tan inverse of b by a. This is the derivative, nth derivative of the given function. Now find the nth derivative of the following: y is equal to e raised to 8x cos 6x plus 7. Again here differentiating with respect to x, so d by dx of this product, so you have to use the product rule. First function as it is derivative of the second plus second function as it is derivative of the first. So cos of 6x plus 7 its derivative is minus sin 6x plus 7 into d by dx of 6x plus 7, its derivative is 6, and here e raised to f of x into f dash of x is 8. So here I will take a 2 common, 2 e raised to, it takes common from both these terms, and this positive term I will write first and this negative term I will write in second. So dy by dx is 2 e raised to 8x into 5. This I have adjusted this 5 just now. In previous example, what we do, we have what we did, we have adjusted root a square plus b square. So here the root of 4 square plus 3 square, that means root of 16 plus 9, that means root of 25, that is 5. So we have to adjust, multiply divided by 5. Then this 4 upon 5 is nothing but cos alpha, and this 3 upon 5 is nothing but sin alpha. So that their ratio sin alpha upon cos alpha is tan alpha is 3 upon 4, equation number 1. So 2 into 5 is 10 e raised to 8x cos a cos b minus sin a sin b is cos of a plus b. So this is the first order derivative. Now again differentiating with respect to x to find the second order derivative. So again we have to use the product rule. First function as it is derivative of the second plus second function as it is derivative of the first function. So d2y by dx square is 2 into 5 is 10 e raised to 8x into minus sin 6x plus 7 plus alpha into d by dx of 6x plus 7 plus alpha. Here this f of x, its derivative is 6. So again I will take 1 2 common, also e raised to 8x common, and then this positive term I will write the first and this negative term then I will write it in later. So 2 into 5 is 10. So and again I will adjust 5 just like previous. So multiply divided by 5. So here I am getting 2 into 5 is 10 and 2 into 5 is 10. So it becomes 10 square. 4 upon 5 cos of, now this 4 upon 5 is cos alpha and this 3 upon 5 is sin alpha. So e raised to 8x 2 square 5 square cos alpha cos 6x plus 7 plus alpha minus sin alpha into sin 6x plus 7 plus alpha. So cos a cos b minus sin a sin b is cos of a plus b. Then this 2 square plus 5 2 square into 5 square is 10 square. So the second order derivative is e raised to 8x 10 square cos of 6x plus 7 plus 2 alpha. This is the second order derivative. Similarly, we can obtain the third order derivative d cube y by dx cube as 10 cube e raised to 8x cos of 6x plus 7 plus 3 alpha. Okay. So by using generalization, we can find the nth order derivative as dny by dx raised to n is equal to 10 raised to n e raised to 8x cos of 6x plus 7 plus n alpha. What is this alpha? Alpha is tan inverse of 3 by 4. So this is all about exercise 1.5. So now next we have to go for miscellaneous exercise.